So good evening and good morning, ladies and gentlemen. A warm welcome to our webinar, IoT Security, Exposing Vulnerabilities and Building Resilience. I'm Anirban, your moderator for today's session. At the end of the webinar, we'll have a Q&A session as well. So please have your questions ready and please feel free to type the same on the chat box. We'll take it one by one. So today we embark on a journey through the dynamic world of IoT, a realm where billions of connected devices shape how we live, work, and interact. As these intelligent systems enrich our lives, they also bring new risks and unseen threats. Our mission is clear: to expose vulnerabilities, understand threat vectors, and build resilience that safeguard our connected future. In an era where one compromised device can impact entire network, IoT security is no longer optional. It is essential. So this webinar aims to illuminate the path towards stronger defenses, smarter design, and proactive strategies that protect both people and systems. Together, we'll explore real-world incidents, analyze IoT threats, and discover practical ways to turn weaknesses into strengths. This is more than a discussion about technology. It's a call to action to build digital trust in a hyper-connected world. And today, I'm honored to have on the panel Rinkle Shah, Senior Director, Systems Engineering, Udit Chavra, Senior Security Analyst, and Swapnil Naik, Head Cybersecurity Practice at ACL Digital. Their expertise will obviously greatly enrich today's discussion. So let's talk about us. So let's first talk about Alten Group. Next slide. Our parent company, the Alten Group, is headquartered in France and has 50,000 plus globally deployed employees. We have served upwards of 6,500 clients and are still counting. We have a global presence in 30 plus countries and have grossed a turnover of $4 billion last fiscal year. Now let's talk about ACL Digital in general. So ACL Digital is 100% wholly owned subsidiary of Alten Group. Next slide. We have served the industry for over 3 decades and created a niche in almost every industry vertical out there. We have catered to Fortune 100 and Fortune 500 companies in digital commerce, health tech, med tech, retail tech, life sciences, telco and NEM, and tech domains. Our customers are industry ISVs who cater further to the provider industry. Now let's talk about a few key differentiators. So domain expertise, deep industry insights, enabling tailored client-focused solutions. Proven delivery, consistent record of successful high-quality IT projects, end-to-end capabilities, full spectrum services, integration, development, data, cybersecurity, and consulting. Innovation-driven, ongoing R&D ensures agility and adoption of emerging tech. We are client-centric, collaborative approach fostering satisfaction and lasting partnerships, and strategic alliances, strong partnerships we have with some of the top tech vendors for superior delivery. Next slide. Now let's talk about today's agenda. So the best part, you will be meeting the experts who are shaping the future of secure IoT innovation. So they are our speakers for today. Now, how devices, data, and intelligence connect to form a unified IoT network, and you would be able to understand through our end-to-end IoT ecosystem the essential components that make IoT systems smart, scalable, and connected. So you will be able to understand through our IoT building blocks, multi-layered defense strategies securing devices from edge to cloud. Our IoT security layered approach will tell you that. Techniques to test and strengthen IoT resilience against evolving threats. So we have a IoT security assessment as well. And the best part about this webinar is we will show you a live real-world IoT vulnerability case and their countermeasures. So in that demo, we will be exploring that. Cybersecurity Center of Excellence, our hub driving innovation and best practices in cybersecurity. How our solution enables secure digital transformation across industry. industries. And obviously, last but not the least, we have Q&A where you can engage with our experts and explore deeper IoT and cybersecurity insights. Now, ladies and gentlemen, let me introduce you to the panel in detail. So I'm delighted to introduce Mr. Rinkle Shah, Senior Director, Systems Engineering. So Wrinkle is a seasoned technology leader with deep expertise in embedded systems, IoT, and semiconductor technologies. He leads a 350 plus member global engineering team delivering product development and QA solutions for 30 plus customers worldwide. With experience spanning roles from developer to solution architect to business unit head, Wrinkle has been instrumental in driving innovation, operational excellence, and strategic growth across industries, including consumer electronics, automotive, healthcare, and industrial IoT. Please join me in welcoming Mr. Wrinkle Shah. I'm also excited to introduce Mr. Udit Chavra, who is a senior security analyst and a distinguished cybersecurity professional. Udit specializes in offensive security with deep expertise in web, mobile, and IoT penetration testing. His contributions have earned him a place in the Hall of Fame of leading organizations like Vodafone, ACES, WithSecure, and Stanford. He has delivered impactful security sessions at the Intelligence Bureau and several global conferences. As a core team member of OWASP Ahmedabad and former ethical hacking lead at Google DSCGIT, he has published CVEs and contributed to advancing cybersecurity awareness. Please join me in welcoming Mr. Udit Chavra. I'm also excited to introduce Mr. Swapnil Naik, Head Cybersecurity Practice. Swapnil leads engineering delivery team focused on enterprise security, cloud, and storage products. In addition to his engineering leadership, Swapnil heads the cybersecurity practice at ACL Digital, helping organizations strengthen the security postures of their applications and infrastructure. Please join me in welcoming Mr. Swapnil Naik as well. And with this, I hand over the dice to Wrinkle, Udit, and Swapnil. Over to you guys. Thank you.
Thank you, Anirban. Thank you for giving us such an energetic head start. So, guys, welcome to the webinar. We'll first talk about what are the building blocks of the IoT system and how can these building blocks be a part of an IoT system which is applicable to all sorts of different verticals. Okay, so if we look at this slide at the bottom, or the core part of the IoT system is the sensors which collect data. Now, sensors can be temperature sensor, barcode reader. It can be a camera that is mounted on a drone, or a camera, surveillance camera, or occupancy sensor. There are thousands of sensors available in the market. These all sensors, uh, they can be either uh, AC powered, or they can be battery operated. All these sensors eventually gather some kind of data, and they collect the data so that it can be processed and some magic can be done from that data. Now, these sensors are relatively small devices. They may not have the power to host internet connectivity, because internet connectivity is mandatory to take things to a central location. So typically, these devices support low power protocols like Bluetooth, Zigbee, Z-Wave, LoRa, uh, CAN. Now, these protocols can operate at a really low power, so they are suitable for the sensors. And then using these protocols, it connects to the gateway, which is the next layer here, which is called a data acquisition layer. This gateway acts as a aggregator of all the data that is coming across from a close proximity. Now, how close is subjective to the protocol that is used. LoRa has 5 kilometer range, whereas Zigbee has 30 feet range. So it is all subjective to what protocol it is used. And then this aggregator gateway is a bigger device. It is a more powerful device as compared to the sensors. Usually, these gateways are wall or are AC powered, or they can have a sizable battery in it because they have to stay awake almost all the time. They interact with these sensors. They are programmed to gather data from all these sensors. These sensors will have their own communication protocol. So gateway will have a software to decode data out of it, the important information out of it, and it will relay that information to the next layer, which is the cloud platform. Now, there are multiple cloud providers worldwide. These gateways are programmed to interact with this cloud. It can be Azure cloud, it can be AWS cloud, it can be Google, Oracle, and there are many more. These are some of the examples. And typically, all these cloud is a big. It has a big database, big storage capacity. All the data is stored here, and a lot of magic happens once the data is received. This cloud also interacts with different human interfacing applications, which are like, I mean, typically any IoT system is accessed through a mobile app or a web app, or these are typical interfaces through which humans can get into IoT system, get information, configure it, and all that. So cloud plays a pivotal role where these applications talk to the cloud, and then cloud talks to gateway and eventually to the sensors. So cloud plays an integral role here. Now, these are primary building blocks of any IoT system. Now, for example, if the sensors here are, let's say, a thermometer, a blood pressure meter, a weight sensor, an ECG, wireless ECG sensor, and there is a gateway aggregating it and sending it to a HIPAA compliant cloud, it makes the entire system to be a medical system. Now, same thing, if it is switched to a sanitary sensor like a Bluetooth operated tap or a valve which can start and stop water supply, and then building there is occupancy sensor, there are lights which are connected to the gateway, and then the gateway is connected to a cloud, and the cloud is accessed by any admin who is managing a huge community of houses. That becomes a building management solution. So typically, these kind of there are infinite use cases, and IoT is making our lives easier through these kind of sensors, these kind of information available on our fingertips in terms of smartphones, right? So now, once all this data is gathered on the cloud, there can be ML, AI, and ML algorithms running on the cloud, which can do the real magic and can extract a lot of information related to fleet management or predictive maintenance in case of industry, patient patterns. For example, if ECG is of a specific pattern, then they should flag to the doctor, or a doctor should be rushed to the patient, and things like that can be done through these algorithms. So those algorithms can be hosted on the cloud. So typically, these are some of the building blocks. We'll talk about such building blocks in a little bit of more detail in the next slide as well. Can you go to the next slide, please? Now, sensors, as I said, we start from the right, sensor or data collectors. We have used some simple terms so that people can correlate. These sensors, now, as I mean, if we talk about the era 10 years ago, the size of sensors have shrunk a bit. At the same time, the size of the chips that are used in electronics have also shrunk, and the chips have become more and more powerful. So now, with the latest generation chipsets, which are really small in size, but they can do more things than what they used to do 10 years ago. So with the current chipset that are used in sensors and gateways, these chips have become AI and ML enabled. So a lot of edge computing can happen on these sensors and gateways, so that uh, complete data doesn't have to be relayed to the cloud. So that is how these IoT systems are also getting smarter and smarter. Now, so these are the same building blocks, but then these are some differences that are coming into play right now in the current system with the evolution of the electronics, with the availability of ML here. But at the same time, wherever there is connectivity. So sensors are connected to gateway through a protocol, gateway is connected to a cloud through some sort of interface. All these connectivities are places where there can be vulnerabilities. And we'll have Udit talk about that in a moment about vulnerabilities. Uh, at the same time, any cloud platform. So we talked about HML on sensors, we talked about HML on gateway. There can be artificial intelligence algorithm running on the cloud as well. Now, with some processing done on the sensor and gateway, there is that much less data to be sent on the IoT cloud. But all the algorithms have to be tuned in such a way that just the required data goes to the next hop. For example, if the sensor is a camera, then nowadays the cameras are becoming intelligent. They are supporting a lot of rules wherein only the output of the rules. For example, I have marked a perimeter. I have told the camera if someone crosses this perimeter, I want an alert. So only that alert is sent to the gateway and then to the cloud, not the complete stream. So this kind of evolution has happened for the devices. But at the same time, wherever there is connectivity, there is vulnerability. So let us go to the next slide, and I'll welcome Udit to talk about possible vulnerabilities at each of these connectivity layers. Udit, over to you.
Thank you, Rinkel. So now we will dive deeper into the IoT security. So this slide presents a layered security approach for the IoT to ensure the protection across all the level from the device to cloud. So it includes tamper detection and secure boot at device level. Then it includes encryption and key management in communication, network segmentation and intrusion detection in networking, and multi-factor authentication with role-based access in cloud application, which creates a unified, resilient security framework. Okay, so as we can say that as connected devices become more common, they have also become prime target for these cyber attacks. And our IoT penetration testing service helps to identify and eliminate all the security risks across your entire IoT ecosystem. If we talk about us, then as a part of our IoT security assessment, we follow structured six-phase methodology, which you can see in your screen. We begin with the planning, where we mainly define the assessment scope, objective, and identify the IoT assets. At last, we also check for the communication channel. Next, during the training, we review the architecture, firmware, and data flow to understand the environment. In the threat modeling, we map all the attack surfaces, trust boundaries, and prioritize the risks. In the vulnerability assessment phase, we include both manual and automated scans of infra and entire IoT ecosystem. Then we move to the exploitation part where we validate the findings with controlled proof of concepts to highlight the impact. Finally, in report, we deliver a detailed report with risk rating and remediation steps with aligned to OWASP top 10 for IoT, ensuring our clients have clear roadmap to strengthen their IoT security posture. That's it. Now let's focus more on the live demo. Okay, so let me turn on my camera first. So hello all. So now we are gonna take one scenario like where we will see a tiny mistake, a silly mistake of developer, how it can lead to a complete disaster. Okay, so we are gonna talk about this attack chains in three stages. First stage will include card cloning. In card cloning, we will see how physical security can be breached. Then there will be second stage. In second stage, we will talk about exploiting UART, okay, and which includes hardware breach or hardware data security breach. Okay, at last but not least, we will check how communication attacks work or BLE attack works. So to start case each and everything, first of all, let me turn on my VM. Okay. So, as you know that access card are common nowadays, like in you go wherever, like in hospital or hotels, or even in at your company, you will see that we use access card to get in and get out. So now we are gonna talk about how we can clone this card, and that also within the 10 seconds. Sounds like a magic, right? Let me show you. So I have these two cards on the right hand. The first card is with the data in it, okay, which gives us, let's imagine that it will give us access to the organization, to the company, to get in and get out. Okay, and there is another card which is empty card. What we are going to do, we will clone this card into this one. Okay, and to clone, we are going to use this device. Okay, so now let's imagine that how do you start your day with the coffee, right? For tea lovers, you start your day with tea. So you will go to cafe. You are waiting in a queue for your turn for your coffee, and someone just comes nearby to you and clone your card, and that's it. How? Let me show you. Also, one thing I want to highlight here is that this card, like you don't need to keep attacker don't need to keep that card in their hands. If even if it is in the user's wallet, victim's wallet, or pocket or bag, it doesn't matter. It can be scanned by nearby and it's done. So for more practical approach, what I'm going to do, I'm also gonna keep my card in my wallet. Okay, now as you can see, I have kept the card. I have just kept this wallet on that device. Okay, that device is only palm size, so anyone can carry it. Okay, I'm searching for low frequency cards over here, and as you can see on your screen, like it has detected HID prox ID card, which works on EM chipset. Okay, now what we have to do, we have to just simply clone it. Okay, it is simple. Now I'm using this empty card to keep it on the same attacking device. Okay, as you can see over here. So, and we will just take ID of that card. It is identifier for this card which we have scanned. So it will directly write the value of that card in this new card. And it's done. You can see that, right? So how much time did that took? I guess less than 10 seconds. I was just speaking it. That's why it took longer. But in real, it would take even less than 10 seconds. Now you can imagine that how easy it is to clone any access card. Okay. So now we have completed our first stage that we have cloned the access card. Okay. What is our second stage? So let's think from the attacker perspective. Okay, like attacker has cloned the card, has gone visited into the organization. He will look for the devices. What sort of devices? IoT devices, like a router or any smart device. Okay, so for saying we have one more device, as you can see. Okay, this device mainly displays and checks the patient's heart rate, and it notifies the required people when there is case of emergency. Okay, so let me turn on the device just a second. Bear with me, I'm just turning on the device. Okay, perfect. So now for this device, when we see it in open case, like its circuit board, and if you see four legs on circuit board, then you can call it a UART. Now, what is UART? UART is mainly used for the debugging purpose for developers. Okay. So what happens is that developer use it for their testing and debugging purpose, but in production line, in releases, they forget to disable it. And this is where we can take advantage. Sometimes UART gives you access of cell, and sometimes it discloses any sensitive information. So I'm using this UART debugger to read the information of the UART. So first thing we need to do is that to check its baud scan. Okay, now baud is its frequency to know that on which frequency it is working. Okay, in layman term we can call it a kind of a frequency. Okay, so let's first check it. So we can see that I have directly specifically scanned the 9600, and we can see that it is a good baud rate that it is working. UART is working on this baud rate. Now let me just simply open the UART debugging interface. So as you can see, it is displaying average heart rate and the live heart rate. So did you notice how easily it is disclosing sensitive information of any user? Okay, that is why we say that it is important to disable the UART. Okay, so with being said that, we have completed our second stage. Now, the final stage. Okay, let me close this. So, when we talk about the final stage, in last stage, what we will do, we will just trying to falsify the data, which is being communicated over the BLE. Okay, and we will also try to uh, create fake notification or fake alarms to create panic situation. Even we can do opposite that. We can even shut down the emergency alarm so that it can even end up in bigger disaster. Okay, just a second. Let me connect the Bluetooth dongle. I'm going to use BetterCap to check available Bluetooth-based devices. Just a second. Okay, perfect. It wasn't detecting the adapter. Still same thing. Nirut, Aniban, can you please hold on for a while? I need to just connect the Bluetooth. Meanwhile, can you please check for the available ask questions? It will take 2 minutes only. Okay?
Sure, sure. No
Yes.
worries.
Yes.
So, guys, if you have any questions, please type in. And we'll take it one by one. Please, you can type on the chat or the Q&A tab. So we have got a question. So what frameworks or standards should companies follow for IoT security compliance? Uh, Panelist, over to you.
Everyone, thank you. I can take over that question. So companies can use various standards for IoT security across the layers what we have looked at, right? It can be OWASP IoT top 10. It can be iOS hardening for the device hardening, basically standards from NIST. It can be HIPAA, PCI DSS standards for data protection regulation sectors. It can be European standard like ETSI EN 303 or 645 for cybersecurity requirements for consumer IoT devices. So there are various standards which can be followed depending on the use case of what actually is being implemented for that particular IoT devices.
Right. Thank you, Dhanraj. And apologies, people. I mean, there is some technical difficulties here being faced by Udit. So I think we would resume in the next 2 minutes. Please hold the fort. By the way, we have another question. What are the key differences between IoT security and traditional IT security? Panelist, over to you. Anyone would like to take that question?
Sure, I can go again for that. So traditional traditional IT security versus IoT security, there is a lot of differences. The major one, if you can look at it, is environment. In IoT, it is distributed physical devices, which are into uncontrolled environment, which are spread across the globe. Into traditional IT, you will have centrally managed servers, endpoints, desktop systems, which can be managed remotely, or which can be in the same physical location as well. There are resource constraints like in IoT, like limited CPU, memory, power. Into traditional IT, it is like more abundant computing resources, right? And the update mechanism also plays a major role over there. With IoT, majorly what we see is oftenly it is like manual or device specific update mechanism, wherein into traditional IT, it is more of an automated patching endpoint and endpoint management is in place most of the places. The attack surface is also plays a bigger role over there, which includes sensors, firmwares, radio protocols, mobile apps, cloud APIs, which are into IoT. And for traditional IT security, you will see primarily network, OS, application layers, right? So, and if you talk about life cycle, for IoT, it's a long product life, 5 to 10 years with legacy dependencies, right? And with traditional IT is like shorter software life cycle with regular updates. So that's about how it is different and what plays important role over there.
Right. Okay. Thank you. Thank you so
Basically,
much.
yeah, just to add to this, Swapnil over here, the traditional this traditional security that we do for applications is more surrounded around web, APIs, mobiles, and infrastructure, right? But when it comes to IoT security, in addition to what I just said, there's a lot of focus on hardware and on the firmware, right? So typically what you will see is the firmware basically has hard-coded or default credentials. The communications from sensor to gateways or from gateways to cloud is unencrypted, wherein you're sending sensitive data. The firmware's protection is weak. It lacks code signing of binaries that you do that you send over to the devices. It's not tamper proof, right? And then many of these libraries that are shipped onto the firmware are legacy, right? Which means that they carry a lot of vulnerabilities that can be exploited. And then you also have this problem of insecure API calls that you do from your gateway devices to your cloud, right? So these are some of the additional areas that you have to focus primarily on firmware. And on the hardware side, you just need to make sure that this UART and the ports are not open, which generally is kept open for debug reasons, things like that, given the device is down, right? So these are some of the areas that you will see, which you will not see in traditional uh, security assessment that you do for software components, right, that I just called out.
Right. Thank you. Thank you so much, Dhanraj. Thank you so much, Swapnil. I think this answers the question that's been asked by Rujuta. Do
Okay.
we? Yeah, Udit, you're back.
Yes, I am back. There was only one issue, like adapter was.
Fantastic. Over to you.
So let me share my screen again. And sorry guys for the inconvenience. Okay, so let's first discover the devices, Bluetooth-based devices. Okay, to discover Bluetooth-based devices, we just need to start. First of all, let me check the device is started or not. Just 10 seconds. It is not started yet. Okay, perfect. It is now started. So first we will discover Bluetooth-based devices around us. So we will type BLE Recon on. Okay. So as you can see, we are bombarded with tons of devices. Why is that? It is because like we are surrounded with multiple devices. Like if you talk about BLE based device, your watch is connected to your phone, your smart TV's remote is connected to it. Okay, even your earbuds are connected via Bluetooth. So it is normal that you will see you are being bombarded with BLE devices. Okay, so over here, our target device is this, and this is its MAC address. Now, what is MAC address? You can consider it as its unique identifier in layman term. Okay, so we are going to take this MAC address and we will check the properties of the Bluetooth. So now you can see that it has a few properties, services, and characteristics over there, like device name, appearance, and so on. There is also one more interesting property which does not have name with it. When I researched a little bit about it, it was related to heartbeat. But what is more interesting about this? It is this. It has right property. It means anyone connected with it can manipulate it. Okay. Now let me show you how we can manipulate this. We will connect the same device. Okay. One more thing I want to highlight. We need to remember the we can say handle ID of that specific characteristics which we want to exploit. So currently it is 000E. Please remember that because it is related to heart rate and we are going to modify that only. Okay. So to modify that specific property, let me paste the command. And in this device, we have alert signals. Okay. Over here, like some, we can say that some devices contain the buzzer, but over here we have LEDs which will send like alert signals that currently it is emergency situation. Okay, so when I'm gonna hit enter, it will just manipulate or temper the heart rate and we will falsify the signal for the emergency. Okay, please keep your eye on the my video. Oh, just a second. Let me turn on my video. Is it visible now? Sorry. Okay. So keep your eye on this device. Okay. There will be one small LED which will get a blink. Okay, the value is written successfully, and if you will see, there are some light near my finger which I'm moving. Okay, it shows that we have successfully manipulated the heart rate value and we can create a fake emergency situation or else completely opposite of it. When there is alert is generated, we just manipulate it, temper it, and make it look like it is normal. Okay, so these were the three stages, like you can say, uh, how we get into the specific IoT system and exploit a different layers. So we started at the door, then we move inside the device, and finally we tempered the data itself. So this demo illustrates the key truth about that security isn't just about code or a crypto, it's about every layer. Okay. We can't let us in the organization. Open UART gave us control over sensitive information, and unauthenticated and unauthenticated BLE, which has weak permission, let us falsify the truth. Okay. So when we talk about IoT, we should focus on all the layers. So now let me get back to the presentation. So I have highlighted right now that how a small thing can lead to a big disaster. It was just a small example, right? Okay, I have shown all the problems of IoT security, specifically IoT security. Now, if I tell you about only problems and not solution, that will be completely devilish. So now let me talk about us little bit, okay? So about my team. So our security team has delivered more than 250 successful security projects and we all are certified. Cherry on top, we have successfully cleared all the examinations to be certain empaneled security for the government of India. Our team have both manual and DevSecOps automation expertise, enabling our customer to do faster and secure releases. So we actively participate in global bug bounty and responsible disclosure program to continuously test our skills across the miscellaneous domain and technology. This has earned us over a 50 plus Hall of Fame from the Fortune 500, which includes NASA, Oracle, Mercedes, Broadcom, Panasonic, Government of India, Stanford, uh, Cambridge University, and so on and on. Okay, this awards highlights our deep expertise in this cybersecurity. Okay, so let me move to the next slide. Perfect. Okay, now I have told you that what my team do. Now let me highlight what ACL exactly do. So at ACL we have been delivering miscellaneous services like web app, mobile app, IoT cloud or risk assessment security service more than 10 years now. And we have delivered projects across several verticals including fintech, healthcare, data center, edtech, logistic, e-commerce, you name it, we have done it. Okay. So we have a multi-year engagement with our customers and where we expect robust security control to be implemented in their product and our security audits to sell their clients. So as a solution, now you know where to come. So that's it from my side. So over to you for the Q&A. If anyone has any questions?
Thank you, Udit. Thank you, Wrinkle, and thank you, Swapnil and Dhanraj. So do we have any questions here? Please feel free to type. Please feel free to ask, guys. I mean, if you have any questions regarding IoT security or anything. So we have got a question. What are the most common vulnerabilities found in IoT devices today?
Now, when we talk about the most common vulnerabilities in IoT devices, then we can say that it completely depends on which technology they are built on. Because, like, it might be specifically on BLE, then in BLE, we mainly see the weak permission, which I have shown you right now, or weak authentication mechanism. If we talk about like uh, Zigbee or no, chalo, let's talk about the UART, like from the hardware aspects. We have seen many times that the common ports are being uh, enabled, and that leads to the information disclosure. So that completely depends on the IoT device and on which technology it works, and from that we can say that which are the most common vulnerabilities.
Okay. Thank you, Udit. Thank you for answering that question. I hope. Okay. So we have another question. So how long does a typical IoT security assessment take, and what are the deliverables?
Yeah, can you guys hear me?
Yes, Swapnil.
Yeah, so the duration can vary based on the device complexity, the overall ecosystem size, and the scope, right? But typically, the engagement takes around 3 to 6 weeks. Okay, and it involves multiple stages. Like we start with the scoping and planning, which can take about a week, followed by threat modeling, which is to basically identify vulnerabilities in your overall system architecture. Followed by that, we have 2 to 4 weeks of actual identifying vulnerabilities, discovering vulnerabilities, and then trying to exploit them. And finally, in the last week, we basically have the report, which basically clearly calls out an executive summary of our observations. What are the issues? How does it play around with regards to our top 10, right? Which are safe, which categories are safe, which categories are unsafe. And that's overall the duration around 5 to 6 weeks, including the report does include remediation details as well, right? So that which helps the engineering teams to basically fix the defects, right? That could be either in code or it could be in configurations. On deliverables, basically we provide a very detailed vulnerability assessment report, which I just called out, which covers all the defects and and the steps to basically duplicate the issues and the remediations, etc. Besides that, we also have scripts, automation scripts to basically run them to basically identify issues in your hardware, issues in your firmware, things like that. And if there are any POCs that were conducted which were specifically requested, then we have those POC scripts and the overall findings document. So these are typically the deliverables in the engagement. The audit report is so created that it's in line with what the auditors expect. And if there are any specific compliance needs, then there's a compliance report also. For example, if you have medical devices, say in the food sector, then you have to adhere to FDA guidelines. So we provide a FDA report for that. So these are typically the deliverables of any IoT project.
Sure. Thank you, Swapnil. Thank you so much. I hope that answers your question. Do we have any other questions? Okay, how can small or medium-sized IoT manufacturers balance cost and security?
Yeah. Dhanraj, you want to take that?
Dhanraj, you're on mute.
So basically, SMBs can achieve strong security without inflating costs by embedding security early in the life cycle. So typically, we have this concept called as secure by design. So right from the design stage itself, we have threat modeling, code reviews early in the development life cycle, which basically helps us unveil all the security issues early in the game. Because typically, what most customers do is engage vendors for security pen testing just prior to the release, right? Which derails the release, and that can be very costly, especially if you find defects, late in the cycle. Then they can leverage open source tools, cloud native tools, right, which can help contain the cost. And then, the focus is on critical controls first, so that we are able to identify critical issues early in the game, like credentials, the way the credentials are managed, the way the firmware is signed, with the communications are leaking any sensitive data, right? So that's how we basically conduct our pen test for SMBs to basically contain the cost.
Perfect. Thank you, Swapnil. Any other questions? We have another 2 to 3 minutes. If you guys have any questions, please feel free to type. You can send it out to me directly as well. We'll wait for the next 1 or 2 minutes. If there are no questions, then we can end the session. Okay, so we have another question. How can enterprises ensure secure device onboarding at scale, especially when provisioning millions of devices across different networks and geographies? If you want, I can repeat the question. How can enterprises ensure secure device onboarding at scale, especially when provisioning millions of devices across different networks and geographies? Over to you, panelist.
So there are a few different ways to provision devices, secure provisioning. These days, there are chipsets that come out with special provisioning certificates. So as soon as the device connects with the internet, it is straight away provisioned, and it is right now. I mean, it gets connected to the cloud with through whitelisting. That is one way of doing it. Otherwise, there are the conventional ways always exist, but then for millions of devices, typically these kind of ways are used where the provisioning becomes really easy.
So on top of that, what I'd like to add is, uh, while you are deploying millions of devices, what you need to consider overall is secure by design, integrating threat modeling, code reviews early in development cycle. That is part one, and leveraging cloud native security, leveraging security tools and teams to ensure your firmware, your devices are actually secure. There are no open vulnerabilities. What Udit displayed right in the demo are not already open on your devices. They're already closed. They are already tested for security vulnerabilities, known security vulnerabilities. That is two. And then using a managed security service to ensure that all the devices which are deployed are monitored for compliance, for security, for any access or unauthorized access kind of issues.
Yeah, and to make the solution scalable, right? You can have a centralized certificate management so that you can immediately issue keys for new devices to be onboarded, rather than having individual devices, keys, and the manual process, right? So that's one aspect. And the second thing is you can also, that what we have seen is customers having automated provisioning pipelines. So at the moment a device is detected, automatically the CI/CD workflow kicks in, and it helps you to automatically provision the devices and do the required registrations. So that's how you can operate at a scale.
Thank you, Wrinkle, Dhanraj, Swapnil. I hope that answers your question. Do we have any other question? Yes, we do have. Yeah, no, it's not a question, but it's so. Yeah, so the person has another question. How do zero trust models apply to IoT ecosystems, and what are the practical steps to implement them? How do zero trust models apply to IoT ecosystems, and what are the practical steps to implement them?
So basically, with zero trust, what we are saying is that we basically need to ensure that there is very privileges given only as needed, and by default everything is denied, right? So what we do is basically for whatever firmware, if there's an OS on that is shipped, we make sure that that OS, the minimum, we have a minimalistic OS, and all the there are tools where we do CIS based scans to just make sure that all the security misconfigurations, everything is addressed, so that you have all the backdoors closed and the minimalistic permissions, right? so that we make sure that there's zero trust on any devices that's being onboarded. So that's how we take care of that.
Thank you. Thank you so much, Swapnil. I hope that answered your question. Yes, it did. So, any other questions? I think if there are no other questions, we can end the session. Meanwhile, we'll just wait for another 1 minute. Thank you so much, panelists. Thank you so much for sharing your insights, valuable insights rather. I'd like to thank Wrinkle. I would like to thank Udit. I'd like to thank Swapnil and Dhanraj for valuable inputs. I'd also like to thank the folks who joined in. I hope they have learned something new today and got some information about some of the fantastic things we are doing. Yeah, I don't have any more questions. So yeah, I think we can end the session. Thank you so much, everyone, for attending. And thank you so much, panelists, for the pearls of wisdom.